Okay, in this tutorial we're looking at section 9.4, which is on applications. So in this section our applications are often looking at finding areas under log graphs. Okay, and it's not actually in the course about integrating log functions, okay, but I've put it in for completeness, and you can actually use them. There's no problem actually using these identities if you want to use them. Okay, so the integral of log to the base e of ax dx equals x log to the base e of ax minus x, and the integral of log to the base e of ax plus b dx is equal to ax plus b times the log to the base e of ax plus b minus ax all over a. So these identities aren't part of the study design, but you can use them if you like. Okay, what they want us to use is things like integration by recognition, or by finding the inverse function and using y values for the terminal rather than the x values. Okay, so we've got one worked example we can look at, which is worked example 8. Okay, so they tell us that we have a function that's defined as f from 1 on 3 to infinity to r of f of x equals log to the base e of 3x. Okay, now the graph of that is shown here. Okay, and what we need to do in part A is find the inverse of f of x. Okay, so remember, to do that we say, well, let's write it as y equals log to the base e of 3x. Okay, and now we switch our x and y and make it x equals log to the base e of 3y. Okay, now we've got to rearrange for y. So we do our looping method of e to the x equals 3y. So y equals 1 on 3 times e to the x. Okay, and so our inverse f of x equals our 1 on 3 e to the x. Okay, so that's part A. Part B, so they want us to integrate from 0 to 1 of inverse f of x dx. Okay, so that's really 0 to 1 of 1 on 3 e to the x dx, okay, which equals 1 on 3 e to the x from 0 to 1, because we could bring this third out the front. Okay, e to the x just goes to e to the x, bring our third back in, so it doesn't actually change. Okay, and then we can sub in our 1 and 0 values, so we get 1 on 3 e to the 1 minus 1 on 3 e to the 0. Okay, so that's going to, we'll go over here, that's going to give us e to the power of 1 is just e, so we can write it as e on 3, okay, minus, okay, well, e to the 0 is 1, so it's just e on 3 minus 1 on 3. Okay? Part B is, part C is hence find the area of the shaded region. Now the shaded region that they give us, okay, is this blue region in here. So we want to find that region there. Okay? Well, our blue region here, okay, is the same as our red region here. Okay? Which is finding this part here. Okay? Now what we just found though, so this function here in red is actually our 1 on 3 e to the x. That's our red function there. Okay? What we just found is this green region. Okay? We just found this green region here. Okay? So what we want to do is find this red region. So really, if we think about the square that goes around this full region, we find that and take away this green region, we'll get this red region, which is equal to this blue region. Okay? So if we look at this box that goes around here, okay, then what we get, okay, is we have an area of our rectangle, okay, because we're going from here, okay, to here, okay, and then from up to 1 here, sorry, so we go 0, 0, okay, 0 e on 3, okay, up here. We also go across to 1, so a little bit wider here, sorry, to our 1, okay, and then from our, we also go 1, 0, so we've got this square here, okay, so we've got a width, or I shouldn't call it a square, it's really a rectangle, so we've got a width of 1, okay, and a height of E on 3, so our area of it is just going to be E on 3. Right? Which means then that the area of our red region is going to be the area of red, it's going to equal area of our square, if you like, minus the integral of our 0 to 1 of our inverse f of x dx. So we know that area of our square, we just found that was E on 3 minus E on 3 minus 1/3, because we just found in the previous section that this is what this equals. Okay, so that simply means we can go E on 3, take E on 3, okay, is 0, and then we've got negative times our negative gives us a positive 1 on 3, okay, which is going to equal this red region here, which is equal to this blue region here. So really we can say then that our integral for 1 on 3 to E on 3 of f of x dx is also equal to 1 on 3, because this red region is equal to the blue region. Okay, so just to recap what we did there, we had this area here of this rectangle, which was E on 3, because it had a width of 1, height of E on 3, and we need to take away this area underneath, okay, to leave us with the area above, which was equivalent to this area. Okay, so that's actually all there is. It's only one worked example in this section, and then it's the last section for chapter 9.